When you think of empty space, like the vast vacuum between the stars, what pops into your head? Probably, well, nothing, right? A total void. But what if that idea, that fundamental assumption, is completely and utterly wrong? Stick with me because modern physics has turned our entire concept of nothing completely upside down. So we're going to dive into a pretty radical question today. What if the vacuum of space, the very thing we define as emptiness, is actually the most active, the most energetic, and maybe the most fundamental substance in the entire universe? And this is where the big shift happens. The classical view, our gut feeling, is that the vacuum is just an empty stage where stuff happens. But the quantum view? Whoa. It sees it as a turbulent, bubbling sea of pure energy, a place of constant, chaotic activity. So how in the world did physicists get to this bizarre new reality? Well, it all starts with the incredibly weird but totally proven rules of quantum mechanics. Turns out, our universe is built on a foundation of constant, underlying fluctuations. Now, the key thing to get about Heisenberg's uncertainty principle is that this isn't about our measuring tools not being good enough. Nope, it's a fundamental rule of nature itself. It means you can never perfectly pin down a particle's properties. There's an inherent fuzziness literally baked into the fabric of reality.
And that uncertainty has a truly mind-bending side effect. It means the vacuum can basically take out tiny little energy loans. For unbelievably short moments, pairs of virtual particles and their antimatter twins can just pop into existence out of thin air before instantly smashing into each other and disappearing. So the vacuum is constantly just simmering with this ghostly activity.
So here's the crucial takeaway. You can never, ever fully empty the vacuum. Even at absolute zero, the coldest possible temperature in the universe, these quantum fluctuations are still happening. This baseline energy that you can't get rid of, that's called zero-point energy. It's the energetic floor of reality. Okay, I know what you might be thinking. This sounds like some pretty wild, abstract math. But it's not. These phantom fluctuations have real, physical, measurable effects on our world. And the absolute smoking gun for this is something called the Casimir effect. It shows without a shadow of a doubt that this zero-point energy can create a real physical force that you can actually measure in a lab. So here's how it works. Imagine you take two perfectly neutral metal plates and put them incredibly close together inside a vacuum. Now, in that tiny gap between them, there just isn't enough room for all the same kinds of virtual particles to pop into existence. But on the outside, anything goes. This creates an energy imbalance, a kind of quantum pressure, from the outside that's stronger than the pressure on the inside, and it physically pushes the plates together. It's a real force generated from the energy of nothing. Okay, so we've established the vacuum is definitely not empty, it's active. Now let's take this one giant leap further with a pretty radical, cutting-edge idea. Physicists Davide Fiscaletti and Amrit Sorley have put forward a model they call the dynamic quantum vacuum. They ask a really revolutionary question. What if the vacuum isn't just an active stage for reality? What if it's the fundamental substance of reality itself? What if everything we see, touch, and feel is just a different form of the vacuum? This is where the whole idea flips our understanding completely on its head. In the standard model of physics, we think of particles as excitations, like little bumps of energy added on top of a field. But in the dynamic quantum vacuum model, it's the exact opposite. A particle isn't an addition of energy, it's a place where the vacuum's energy has been diminished. It's a subtraction from the baseline energy of space. And just that one single shift in perspective has some absolutely profound implications. It could let us reimagine some of the biggest puzzles in physics. We're talking about the nature of mass, gravity, and even Einstein's relativity. So, what's mass in this new picture? Well, a massive object, like a planet, isn't something added to space. Instead, it creates a kind of dent in space, a region where the fundamental energy of the quantum vacuum is locally lower than the space around it. And that leads to a stunning new way to think about gravity. It's no longer some mysterious force pulling things together. Instead, the higher energy vacuum outside of these two dents is constantly pushing inward. So gravity isn't a pull at all, it's a push. I mean, the researchers put it perfectly. They say gravity is literally the vacuum pushing from areas of higher energy density toward areas of lower energy density created by matter. It's a pressure gradient in the fabric of space itself. And the explanatory power just keeps going. The proponents of this model argue that it provides a physical reason for all sorts of phenomena that general relativity describes with math. Things like the weird wobble in Mercury's orbit, and even the subtle way that Earth drags space-time around with it as it spins. But maybe the most impressive part is that it offers a new physical way to understand Einstein's relativity, and the very real effects it has on technology we all use every single day.
Just think about the GPS on your phone. For it to have any chance of working, it has to constantly correct for relativity. The DQV model explains this by saying that the dent in the vacuum around Earth gets dragged along as our planet rotates. This dragging vacuum is the physical medium that actually affects the flow of time.
So check this out. The model actually unifies two different effects of relativity. General relativity says clocks tick slower in stronger gravity. The DQV model says, yep, that's because the denser vacuum near Earth's mass physically slows down the rate of everything. Then, special relativity says fast-moving clocks also tick slower. The DQV model says, right again, because moving fast creates its own little area of diminished vacuum density, which also slows the clock down. It's one mechanism for both effects. And believe me, these are not small theoretical effects. For a GPS satellite, these two things, one slowing its clock down, one speeding it up relative to us on the ground, add up to a time difference of about 38 microseconds every single day. Without correcting for that, your GPS would be off by more than 10 kilometers a day. The only reason your map app works is because we account for the weird physics of empty space. So, wow, we've gone from thinking of space as an empty void to a seething sea of energy, and now to the idea that this nothing might actually be the source of, well, everything. So what does that mean for the future of physics?
Well, this dynamic quantum vacuum model paints a picture of an eternal, self-sustaining universe. It suggests energy from the vacuum forms particles. Those particles clump into stars and galaxies, and eventually some collapse into black holes, where matter gets transformed back into the pure energy of the vacuum. It's like this grand cosmic recycling program, with no real beginning and no end.
Which leaves us with one final, absolutely tantalizing question. We started out thinking of space as empty. Now we're talking about it being the literal source code for reality. So if the vacuum is the origin of matter, energy, gravity, and time, what other incredible secrets are still hiding out there in the emptiness?